speed over the change in time. So we just take the time, we'll say the speed at 4 seconds, subtract the speed at 0 seconds, and divide it by 4 versus 0. So really you're just taking the average. Okay, so that's 5 minus 10 over 4, which is minus 1.25 meters per second. So why is this negative here? This is negative because the speed is decreasing, and 1.25 meters per second is the speed. So the velocity is minus 1.25 meters per second, and that is the average rate of change of her speed. So that means for every second, her speed is decreasing by 1.25 meters per second. Okay? Another way to think about that is that's the slope of this section of the line. Okay, if you turn to the next page, part C says, what is the instantaneous rate of change at 3 seconds? Well, if you refer back to this graph, the instantaneous rate of change is what's happening right here at 3 seconds. Well, the rate of change over this whole time period is minus 1.25 meters per second. So that's the rate of change at that moment. Okay, also you can think about it is that the slope at that line is minus 1.25. So that's the answer for C, which is on your next page. All right, we have one more question to do today. So Adam and his friend are testing a motion sensor. So this is going to be distance versus time. So often when I'm looking at these questions, I like to just come up with my graph so I can label information as I'm reading, or else I find it difficult and it just seems like a lot of information at once. So it's going to be distance versus time. Your distance starts at 0.5, 4 meters away, so it's going to go up to 4.5, and then how much time do we need? So 10 seconds, 5 seconds, 5 seconds, so 20 seconds total. So we'll label time in seconds and make sure we have enough room for 20 seconds. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay, and we need 4.5, so I'll just do 1, 2, 3, 4, and then I have room for a 0.5, and that is distance. And it's given in meters. Okay, so now I'm at a point where I can start actually graphing something. So Adam stands 0.5 meters in front of the motion center. So he starts at 0.5 meters. Okay. And then walks 4 meters away at a constant rate for 10 seconds. So that means at 10 seconds, he is at 4.5 meters. So I like to draw the dot of where he will be and then connect the two dots. So I'm always thinking, do I connect them with a straight line? Is it constant? Or am I connecting them with a curve and it's variable? So in this case, it says constant rate, so I get out my ruler and make a straight line. Of course, now I don't have a long enough ruler, which you guys will have no problem because you're on an actual piece of paper. Okay, there we go. All right, so there we go. And next he walks 1 meter toward the sensor for 5 seconds. So he's at 10 seconds, so for 5 seconds, so 15, so here's 14, here's 15, he's walking 1 meter, so from 4.5 to 3.5. And then he waits there for 5 seconds. So at 20, he just is still there. So this for sure is a horizontal line. They don't tell us anything about if this is constant or not, so we're just going to assume it's constant. But it's important that you understand that you're making an assumption if I ask a question like that, okay? So let's label our points because that just makes it more complete. So this is at time 0, he's at 0.5 meters. At time 10, he's at 4.5 meters. At time 15, he is at 3.5 meters. And at 20, he's still at 3.5 meters, okay? So what is the average rate of change in the first 10 seconds? Well, we just go to our average rate of change formula. So the change in distance divided by the change in time is the distance at 10 seconds minus the distance at 0 seconds, all over 10 minus 0. So we have 4.5 minus 0.5 divided by 10. So 4 over 10 is 0.4 meters per second. So the average rate of time is for every second he is increasing 0.4 meters. So that is the slope of this line. It's also his speed, his average speed for the first 10 seconds. What is the instantaneous rate of change at t equals 1 second and at t equals 7 seconds? Well, t equals 1 second is here, and t equals 7 seconds is here. So you'll notice for both of them that the slope in both of those times is this 0.4 meters per second. So remember, instantaneous rate of change is just the slope of the tangent, or in this case, the slope of the line at that point. Well, what is the instantaneous rate of change at 18 seconds? So that's here. Notice that the distance is not changing at all with respect to time. So there, it is just 0 meters per second, because there is no change happening at 18 seconds. Finally, take a look at the last question asking you to graph between speed versus time, and think about what that is going to look like. It's going to look quite different. Okay, so speed versus time. So here's our time, still in seconds, and here's our speed in meters per second. Okay, so we still have 20 seconds, but I'm just going to increase this by 5s, and you'll see why in a moment. So what is happening with his speed? Well, for the first 10 seconds, he has a speed of 0.4. For the next 5 seconds, it's actually, his speed is whatever the slope is of that section, okay? So you have to go back and look between, we want the speed at 10 to 15 seconds, right? We need that. So that's distance over time is how we find speed. So the distance at 15 minus the distance at 10 divided by 15 minus 10. Now I'm taking the absolute value of that because we're not looking at velocity. Okay, velocity has positive or negatives. We're looking just at speed, which is just the absolute value of velocity. So if you put those points in, you'll get 0.2. Okay, so actually the velocity is negative 0.2 if you put these points in, but the speed is just 0.2 meters per second. And that should make sense because that section of the graph has a much shallower slope than the first 10 seconds, just steeper slope. And then from 15 to 20 seconds, look up at the graph. There's no change of speed versus time. So that actually has a speed of 0 meters per second because he's just standing there. There's no speed. So from 0, we only have a max speed of 0.4. So we can just do 0.1, 0.2, 0.3, and 0.4. So up to the first 10 seconds, the speed is just 0.4, okay? And then starting from 10 seconds to 15 seconds, this is a piecewise function here, okay? you're at 0.2. And then from 15 seconds to 20 seconds, your speed is 0. So this is what is called a step function, okay, because it looks like steps. So it's a special kind of piecewise function where you only have horizontal lines. So that is the lesson for today. So a few takeaways I'd like you to think about. Number 1, read the questions carefully, label your graph, make sure you have the scale exactly how you want it before you start sketching things. Number 2, pay close attention to the questions, whether it's talking about a constant rate or a variable rate. That will determine if you have a straight line or a curve representing your change. Also, make sure you know what it's asking you to graph. If it's speed versus time or it's distance versus time, obviously your graphs will look different depending on what you're actually graphing. And also finally, just remember how to calculate average rate of change versus instantaneous rate of change. Average rate of change is between 2 points. You find the slope between those 2 points. And instantaneous rate of change, you're just looking what is the slope at that exact point. So thanks for watching the video today, and I hope you learned lots.